Hey everyone, I hope you're doing well. For the next few weeks, I'll be releasing small demos showing off a bit of my programming knowledge, which will hopefully help you guys out. Before I get into this demo, I'd like to say a little bit about myself and how these demos will actually work. So I myself focus on 2D and 3D environmental and inorganic design with an intermediate knowledge of Unity 2D and 3D mechanics. In these demos, I'll be focused on showing off the programming portion of these projects, so I'll be using the default game objects from Unity with textures and materials added onto those objects so that we can actually tell the difference between what I'm actually working on. These demos will become more advanced each week as these are being released in the order that I've actually worked on them. One last thing I'll mention, then we'll get to the tutorial. In order to show off the code and proof of concept, I've split my desktop into multiple pieces. I've cropped the Unity window so that only the scene view and the respective inspector sections will be visible. With all that info out of the way, let's get on to the tutorial. In this video, I'll be showing you how to get the core components of a pinball game to work. Keep in mind there are various ways to tackle each problem, so the way I've created a solution can be very different from someone else's. So to start, I'll go through the basics of how the flippers will actually work. So the flippers will be utilizing a 2D hinge joint from the Unity physics engine. To set up this joint, two game objects are going to be needed. You're going to need the anchor and then the actual flipper itself. So in the scene view, I've put a different material on these two pieces to help show you what is actually being affected. And as you can see in the inspector view, I've set the anchor game object, which is that little cube, into the connected rigid body slot. Then I have to set the lower and upper angles to limit the joint movements to mimic a pinball flipper. So this will actually give us the full range of how the flipper will actually flip up and how it'll get back to its resting position. So thanks to this actual joint, the script will actually be somewhat short. So first, I've got to create a bool so I can differentiate between the left and right inputs. Obviously, we've got two different flippers. If we don't differentiate between the two, then one button will activate both of them. So I made this bool public so it's actually visible inside the inspector view. According to the script that I actually wrote here, I have to make sure that the right flipper game object has the bool checked on. So this will actually be able to differentiate between both the flippers. Next, we got to get the key input. This demo here, I've set it to left and right control for the left and right flippers. So finally, if either of the buttons are pressed, it'll activate the joint's motor, which will create the flipping motion. Once the button is released, the motor will be turned off and the flipper will fall back to its resting position. If you want to take a look at the inspector view, you'll see me hitting the button a couple of times and you'll actually see the checkbox for the motor turn on and off. Next, we got to do the bumpers. So the key for this script is recognizing the point of contact between the ball and the bumper, then adding a force to the ball from that point of contact. I've added lights and particle systems to indicate when the bumper has actually been hit. So the first thing I have to do is get the light and particle system components from the inspector so I can call on them later on in the script itself. So when the game starts, the particle system is stopped, so no particles will be created and there won't be any loops until a hit has actually happened. So next, I have to search for the color of the bumpers itself. In this project, I've got two different colors happening. I've got white and I've got red. White are the normal bumpers that are just kind of scattered throughout the actual pinball table itself. Red is going to be the ones that are actually right beside the flipper. Naturally, in the update method of the script, I've got it searching for these two collision colors. The two collision colors are actually going to be blue and green respectively. So the white one will change to blue when hit and the red one will change to green when hit. In the update function, we've already got the data from the collision, which I'll get into a little bit later. So if either of these colors are detected, we're going to start a timer. So what this timer is going to do is when it's actually reached past half a second, the light, the timer, and the particle system are all going to be reset to the original values. The light will get set back to either white or red, the timer will get set back to 0, and the particle system will once again be stopped. Next, we're on to the collision. First thing we're looking for when this collision happens is the color of the bumper. If it's red or white, we are looking at changing it to blue or green. Next, particle system. So the particle system finally starts looping, and as stated before, in the update function, it'll only last for half a second. So as long as that timer is less than half a second, we'll have the particle system looping. Once it reaches over half, it stops. Last but not least, we got to add force to the ball when it hits a bumper. We're adding a negative force to the ball here because if we add a positive force, the z-axis of the ball is actually pointing towards the bumper. If we add that positive force, nothing will happen because it's already pushing into the bumper. so it would actually just roll right off. As you can see in the scene view here, I will be changing it from a negative force to a positive force, just to give you guys the idea. We actually need a negative force to push the ball back out. Now, onto the kickout. The kickout is an object that will absorb the ball and hold it in place for a set amount of time. But the kickout I'm making here will actually utilize a 2D point effector, which will be activated once the ball has passed through its trigger area once. For the purpose of the demo, in the scene view here, I've set the area to be triggered immediately. When the game starts, the point effector will be disabled, the light and particle system components need to be retrieved, and then the particle system itself must be stopped. Based on the data from the collision, which I'll get into more detail a little bit later, the point effector will be enabled. When it's enabled, a timer will start, the color of the light will change, and the particle system will start to play. But once 3 seconds have passed, we're disabling the point effector, light will return to white, particle system will stop, and finally the timer will be reset to 0 to ensure the kickout can be reactivated during play. This is where it gets different from the bumper. The kickout will be managed by a trigger instead of a collision. If the trigger area is hit by anything, a counter will increase. The trigger can only be hit by the ball, so there's no need to specify what exactly is being hit. When the counter is greater than 0, the point effector will be activated, and once activated, the counter will be set to 0 to ensure the point effector can be reactivated once again. The inspector here shows how the effector is laid out. There are only a few settings here that I will be changing. The force magnitude, we need to set this to a negative value here so that we can actually absorb the ball into the middle of the kickout. If it is a positive, the ball just won't actually even get into the center of the kickout area here. Force source and force target, both are going to be set to rigid bodies here. The reason for that is I have rigid bodies on both the ball and the actual kickout here. Having the rigid bodies interact just gives us a better collision interactions. So the biggest thing here is actually the damping factor. So both the drag and angular drag here, I have over 100 value for them. This is what's actually going to slow the ball down, and because of the ball slowing down, the force magnitude will be able to pull the ball into it. So with these values set, the point effector mimics a kickout hole very accurately. With these scripts and scene views shown and explained, here's a demo of everything together. If you have any questions or comments, feel free to leave them below. That's all from me. Have yourselves a good day. Cheers.